Hey, welcome to AP Human Geography Review. Tonight is February the 7th. We're looking at the Green Revolution. I see that Ms. Bannert has her whole class on the Fiveable review tonight, which is spectacular. Remember, like always, if this is something y'all find is helpful, let your friends know about it, and tell them that all live reviews are now free. And, if you want to be able to see all the previous reviews for the course, especially as you get a little closer to your AP Human Geography exam, which is quickly approaching, then you got access to the recordings with the Fiveable Plus account. There's my social media. I've been trying to post some stuff up there on my Facebook in particular because more and more people have been doing that. So I'm going to try to do better about that. Here's my quick advertisement for what we're doing here on Thursday nights. Every Thursday night from 7 to 8, by the way, I'm going to be here doing this all the way up to the AP exam. All Fiveable live streams are now free, as I just now said. The Fiveable Plus account gives you access to all the past live streams. If it's helpful, let friends know about it. Keep in mind that on April 1st, which is my daughter's birthday, the cost of Fiveable Plus is going to go up a little bit. I got a question. Would it be worth it to pay the $20 Fiveable Plus? I think so. You get access to, like I said, reviews on the whole course. It comes down to how you feel in terms of reviewing. So if you feel like it's helpful to sit through these right now, it will be helpful to buy the review. And one other thing, too, that I want to point out to you guys is you're looking at, with any review options, you're looking at somewhere around $15 to $20 for any review for a lot of the apps for this. So you've got $20 in the face of $1,000 or $1,200 for the cost of a college class. So if you pass the AP exam, you'll get college credit for the course. I think $20 in the light of that is a pretty good deal. I would even recommend, in addition to just Fiveable, maybe even get a review manual as well. The AMSCO Human Geography book is probably my favorite. So I definitely think it's worth it. Okay, well. I'm trying to learn how to mark my questions here. I haven't been doing that very well. So anyway, as y'all have more questions, feel free to click on the Ask a Question, let me know it. Also, feel free to put some in the comments, but Ask a Question will allow me to timestamp it in the review. That's another thing, too, you get access with the Fiveable Plus account is you get access to my PowerPoints as well as notes on where to find information in the live streams. So without any more rambling on from my part, let's go ahead and get through it. Jeez, I never went and updated all my objectives on this. I got a little slack, I suppose. So we're talking about what is the Green Revolution. We're going to look at the good and the bad of that. It hasn't been successful everywhere, so we're going to talk a little bit about that. We're also going to finish up looking at some GMOs and talking about the pros and cons of GMOs. So kind of looking at an extension of what we did last week, talking about the first and second agricultural revolutions. We're going to continue to see how agriculture has changed over the last, 80 or so years. So just in that sense, a quick review, the Neolithic Revolution is the same as the first agricultural revolution. It is the invention of agriculture. It's when people stopped being hunters and gatherers like we were for the majority of human history, and we started settling down and systematically cultivating the earth so that it can produce crops for us, and we can have larger populations, and people can specialize in their work, and it kind of led us to where civilization is going to start to flourish, and eventually to where we are today. The second agricultural revolution is going to come, with kind of just before and in conjunction with the Industrial Revolution. It's a major change in how we produce goods, in particular commercial agriculture, with the mechanization of agriculture. In other words, the Industrial Revolution kind of applied to agriculture. How do we use machines in order to enhance the amount of food we're able to produce to support larger populations? And then, let's see. Second agricultural revolution caused demographic changes. This is something that I'm not sure if I'll put in the last presentation, but I wanted to make mention of this, is that in, I believe it was the year 2010, 2011, about the same time as we hit 7 billion people worldwide, the world globally, we had about 50%, more than 50% of our people on Earth living in cities. For the majority of human history, for the majority of agricultural history, people have been peasant farmers. In the United States, we finally got to where we had more than 50% of the population living in cities. around the year 1930. This is due to changes because of the agricultural revolution, the second agricultural revolution. More and more people were able to not work at a farm. They didn't have to. I didn't have to go in my backyard and grow crops to support my family. I was able to buy crops that were produced by large landowner farmers using capital goods like machines to more and more food. So that led to demographic changes. Less farms, bigger farms, less farmers. The majority of those people that used to be farmers started going to cities looking for opportunities there. It is kind of similar to, if you guys remember back in population, when you're looking at the stage 2 and 3 of the demographic transition. This is happening in that stage 2 and 3 range within the demographic transition. And then finally, in the 1900s, population continued to grow exponentially. All right, global growth rate was higher than today. Interestingly, I read an article just today where people are starting to kind of doubt the UN projections on population. I have to put that on my Facebook page for you guys. It doesn't really pertain to what we're doing here. But what I want you guys to take from this chart that I put up is this is looking at time it took for world population to double. Now, y'all remember doubling time from back in Unit 2, right? It's exactly that, the time it takes for population to double. And if you look here, you're looking at it took 594 years for us to get from 0.375 to 0.75 billion people. All right, now, to give you an idea, there's 7.5 billion people in the world today. This is still less than 1 billion people in 1737, right? But then it only took 206 years for us to get from 500 million to 1 billion people, okay? Then 125 years to get from 1 to 2 billion. That's pretty crazy. But here's what was happening in the mid-1900s. Just like I said in the previous slide. It only took us 76 years to get from 1.5 billion to 3 billion people. All right, so there are people today that they're going to be old at this point, but we have people alive today that were alive before the world or around the time the world hit 3 billion people. That's insane to think about when you really put it in perspective. So from 2 to 4 billion, it only took 47 years. That happened by roughly, 1980? It was what it looks like here. And so on and so forth. Now, notice that as you get here, doubling time, it gets very small because we have a ton of population growth going into this area here. As time goes on, population or the doubling time is going to decrease because population growth is going to start slowing down. All right, so right now we have slower general growth than we did in the mid-1900s, but our population is still growing a lot because of demographic momentum, which hopefully you guys remember from Unit 2. If you think about this was the only dude worried about the amount of resources relative to the growth of global population, you're wrong. He was worried about it a lot in the 1800s, but oh my goodness gracious, I don't know if you guys have seen the Avengers yet. It's still something we think about today, right? This level of population growth and our inability to support large populations due to limited agriculture and limited resources is still something that people look at and question today, and it pops up in our popular culture, just like we see with my boy Thanos in the Avengers. Let me look at this question. So population growth is directly affected by the food production increase due to agricultural revolutions. And our doubling time is decreasing due to a higher population compared to food. Let's look at the first one. Population growth is directly affected by the food production increase. I'm going to say yes. The two work hand in hand. Anytime historically you see where there's surplus food, like for example, if you're looking at the dawn of civilization in Mesopotamia and Egypt and Indus Valley, these populations were able to grow because people had more food to eat. It's like this. When you're looking at the stage 2 of the demographic transition model, when you have more and more people living to be older, all right? So birth rates never increase, ever. Birth rates never, ever increase historically. They only go down, all right? But death rates decrease, starting with stage 2 and 3 of the demographic transition model. The reason why death rates start to decrease is because largely of more food because of these agricultural revolutions. So the reason why population started to spike in conjunction with the industrial, or in other words, second agricultural revolution, is because there was more food for people to eat and they're not dying as fast. All right. So yeah, I would say that those two things go hand in hand. doubling time is decreasing due to higher population compared to food. No. The reason why doubling time is decreasing is because as a planet, we are globally, and I don't like to say to use this example, but it fits. Globally, we are basically in stage 3 as a planet on the demographic transition model. Now, to go back and look at that, what's happening when you have countries that are beginning to become more developed, they start having less kids because they realize those kids are going to live longer. And it gets really, really, really hard to support those kids. One, in urban settings, which is where most people are moving. And two, if you want to have decent livelihood, you don't want to have 5 kids because that's 5 kids colleges, that's 5 kids food to eat, that's 5 kids toys, so on and so forth. So that's the reason why doubling time is starting to slow down, is because according to UN projections, in 2050, we're going to have about 9 billion people. And 2100, if things don't change based on UN projections, we're going to have about 11 billion people on Earth. And then most statisticians and most demographers say that population will start actually decreasing about that time, because more and more of the world will be essentially living in a developed country. All right, so does that answer your question? I hope. All right, so this one here is Paul Ehrlich. Again, looking kind of at a crossover with Unit 2 here. Ehrlich wrote the book, The Population Bomb, and he was concerned because he looks at a country like India that's super poor in the 1960s or so, and he says the population there is growing rapidly, really, really fast. What the heck? How are they going to be able to support themselves with the amount of food they're currently producing? And so it's very, very Malthusian. And Paul Ehrlich was saying things like, hey, we're going to have like 100 million people, or some unbelievable amount of people, especially in India, are going to die due to basically starvation, essentially the same natural checks in a way that Malthus was talking about. And so people like Ehrlich realized the worst growth was occurring in regions that were already poor, like India. Population growth was also happening in the United States. I want to point that out. But the poorest places were the main concern here. This here's what Ehrlich said. I got a question I'm going to answer in just a minute. The population bomb says, or he says in the population bomb, in the 1970s and 1980s, hundreds of millions of people will starve to death in spite of any crash programs embarked upon now. India couldn't possibly feed 200 million more people in 1980. So very, very much a neo-Malthusian. He was kind of the leader of the pack in the 1900s for those who agreed with Malthus's predictions ultimately. Let's look at this question real quick. How does agricultural revolution occur? Is it a gradual process, or does it occur in a short amount of time? Well, one of the things that I mentioned last week is, let me go ahead and hit the button here, is that a revolution really essentially is a sudden drastic change. Now, the agricultural revolutions that we're looking at, especially Neolithic, it didn't happen suddenly by our standards. It happened over a course of several thousand years. But if you look at the fact that human history, modern humans go back about 200,000 years, and for most of that time we were hunter-gatherers, a couple of thousand years really isn't that much time. So yes and no, revolutions can take a long time by our standards, but usually you think about it as something that happens in a relatively short amount of time in the grand scheme of things. The agricultural revolution, you could say, kind of started around 1700 and lasts until about 1850. And then some would argue that the green revolution we're about to be talking about it's still happening today, or at least maybe a different phase of it. But the green revolution starts about the mid-1900s. So Ehrlich here was very much a team pessimist. When I wrote this here, still Ehrlich, I think. Yeah. When I wrote Population Bomb in 1968, there were 3.5 billion people. Since then, we've added another 2.8, more than the total population, 2 billion, when I was born in 1932. So that's Ehrlich breaking it down. But here's the problem, Mr. Ehrlich. Norman Borlaug. Booyah. Norman Borlaug. He is known as the father of the Green Revolution. He was a scientist, okay, and he was young and ambitious and super gung-ho about solving the world's problems. And one of the main things he wanted to do was solve hunger issues in some of the most poor places. And he has a PhD in plant pathology. He goes into Mexico and he starts looking at Mexican farmers and trying to help Mexican farmers. And they're like, wow, who is this guy? He doesn't know what he's doing. And he was very, very determined to help out. And through research and growing and a lot of hard work, he ends up creating a super strand of wheat that is susceptible to a lot of the harsh conditions that were keeping yields low for farmers in Mexico. What the heck is a yield? All right, so if something yields a lot of food, that means it produces a lot of food. So what we're looking at here for yields is that's the agricultural term for how much of a product you're able to produce in agriculture. So yields were low. That meant they weren't growing enough food to support the population. They struggled against disease and famine of their crops. So their crops were disease prone and famine was happening and they weren't able to feed themselves. They didn't have enough food. Borlaug's goal was to create wheat that could resist the diseases. If they can resist disease, that means it's going to grow there's going to be more products, it's going to be higher yields. So he ends up crossbreeding several wheat varieties to produce a form of wheat that could produce high yields in a range of different conditions. All right, now I'm not a scientist, all right? So I can't really get into the really deep details about what he's doing here. You don't need to know that, all right? Because what you're looking at is, again, like I say in every presentation, the spatial perspective. You want to see how this ends up helping people across the globe. One of the problems that he ran into right off the bat is that the new wheat that he was able to grow, it was so productive that the wheat would actually make the whole plant fall over. And if the plant falls over, then the yields are wasted. So in order to further help the Mexicans with their agriculture of wheat, he ends up further crossing it with a dwarf wheat plant that I believe was from Indonesia in order to make the wheat stalks just as bushy, but also super short so that the wind wouldn't knock them down. And it was an overwhelming success. The work in Mexico not only had profound impact on Dr. Borlaug's life and philosophy of agriculture, research, and development, but also on agricultural production, first in Mexico and later in many other parts of the world. It was on the research stations and farmers' fields of Mexico that Dr. Borlaug developed successive generations of wheat varieties with broad and stable disease resistance, broad adaptation to growing conditions across many degrees of latitude, and with exceedingly high yield potential. What I wanted you guys to get from that quote right there is that they could grow in all kinds of places, some hot, some a little bit cooler. It could be in dry places. They still need water, but they're somewhat drought resistant and adaptive to growing conditions of all kinds. They also are resistant of diseases and grow more yields. So kind of a big deal. Borlaug won the Nobel Peace Prize for his work in 1970, having essentially saved the lives that Ehrlich was sure would perish due to the discrepancy between population growth and low food production in the 1960s. So you got to think about this for a second. In the same way that we were able to, as human beings, find creative ways to prove Malthus wrong, we did it again with the Green Revolution. This time, not with the way we produce, using things like machines and new crop rotation techniques and better seeding and all this stuff, but we actually use scientists, really, and crossbreeding as a way of doing this. So this process is known as hybridization. One thing that I really want you guys to know is that a selective breeding and things like this isn't anything new, all right? So what the Green Revolution does is it looks at things that we were kind of doing for the entire time that agriculture was going on, and it really, these scientists were able to do it in ways that are way faster and with way more, I guess, precision. I'll show you what I mean in a second. Mexico, Pakistan, India, these are places that greatly increased their food production as a result of Norman Borlaug's work. Mexico they go from having to import wheat and food to actually exporting it on their own. India, same thing. I might have that in here. I don't. You need to know that Mexico and India and Pakistan really benefited from this. India in particular, their population is still growing. They're going to overtake China's population over time, but they're now able to produce enough food to sustain that without all the death and despair and gnashing of teeth that what's his face Ehrlich was talking about. The Green Revolution was more than just high yield crops, though. Okay, it still required fertilizer, right? It also still required pesticides, and it still required good irrigation. So this stuff, these new seeds might be resistant to some of these conditions, but it's not impervious to them. In order for countries to benefit from them, they need good infrastructure. Y'all, this is important. What we're going to do, we're not close to done, but I want to take a minute to talk about why this didn't work for everyone. And when we talk about infrastructure, just to make sure everybody knows it, and we don't have someone that I'm not going to assume you guys know what this word means, but you need to know, especially for coming units, is the basic physical and organizational structures and facilities, buildings, roads, power supplies needed for operation of a society or enterprise. In other words, railroads, roads in general, buildings. These are things that we talk about when we talk about infrastructure. So if you've got crappy infrastructure and terrible roads and no railroads, how in the world are you going to get fertilizer, pesticides, and good irrigation? See where I'm going with this? So if you look at a couple of maps, this right here is this is India 1909 general map of railways, and you can see that's pretty extensive. Does anybody know why India has so many railways in 1909? Who controlled India in 1909? Anybody remember? There we go. Good job, Logan. Yeah. Okay, there we go. So it was a British colony, and not only was it a British colony, it was the jewel in the crown. In other words, it was their best and most productive colony. It was one that they truly, people from Britain lived there, and they had their own sepoys or soldiers and stuff that served them, and local officials. They were Indians, but they really instituted their culture and their technology in India. And you can see that with their railroads. So when it comes time for these dudes here to be able to get fertilizer, pesticides, machines, and stuff like that throughout their country to change their agriculture, you can understand that they had the infrastructure necessary to support that because of the British legacy. I have a question. Let's take a look. So these revolutions only be possible if these conditions have a higher level of development. Let me think. The conditions have to be right for any kind of a revolution like this. So yes-ish, I guess. If you look at the Neolithic Revolution, the conditions that made that possible was the end of the Ice Age. It just couldn't have happened whenever half the ocean, the glaciers were still on large chunks of the continental world that we're familiar with in Europe and the Americas and all that. So that's why it really helped to bring about the Neolithic Revolution. The second agricultural revolution, which preceded and coincided with the Industrial Revolution, really happened in Great Britain first because of several factors. They had a lot of good resources. They had a lot of natural waterways and natural harbors and things like this. They didn't have to fight battles on their land. So Napoleon never wrecked their farms and their facilities in the same way he wrecked half of Europe in the 1800s. So you were able to see the conditions were just good in Great Britain. It didn't take it long before the second agricultural revolution and the industrial revolution began to facilitate to other European countries. But they did start in what would be considered the most developed countries first. Now, China also began industries about 100 years prior to the Europeans, but culturally they looked down on merchants and things of that nature, and they kind of upheld agriculture as like a more noble economic job essentially. And so they were more for agriculture and kind of turned a blind eye to industries when they were ahead of the game. So I'm done with that one. And it's Green Revolution achievable without certain variables. Well, the Green Revolution was something that was started essentially by scientists in developed countries. So yes, but the reason why it was able to be effective in some of the poorest countries was because of good infrastructure, as I'm showing you here with India, as well as, I'm sorry, I meant to like I was answering that. But if you look at other places where the British were, for example, India, Pakistan, Mexico had railway development in the 1800s as well, and in the 1900s, and so they had infrastructure in place there. Africa, no roads, no railroads, no irrigation, water shortages, etc. Right? And when I say water shortages, like they literally don't have enough water. Right? There's a shortage of actual fresh water in many African countries, and many of them are landlocked. The borders are superficially drawn by Europeans. All these different issues kind of fed them into not having the right conditions, as we were just talking about, for the green revolution to be effective in these countries. So it can't even transport tools, capital goods. When we talk about capital, remember we're talking about the investments that people are able to make. You got to be relatively well off in order to invest in capital or capital goods, in this case, like the machinery required to do the agriculture. Here is Africa's major roads and railway network. So you're looking at a lot of things here. The main thing, though, is that the red and the black lines represent roads and railroads. And for Africa to be so extensive as it is, you're not looking at one country, you're looking at the continent as a whole. And you can see that places that have the most are going to be the places that are most urbanized. But a lot of people in Africa still live in rural areas and support themselves through subsistence agriculture. And they're not able to invest in green revolution technology. And if they did, how would they get all the machines and the irrigation and things like that they need in order to be successful? The Green Revolution encouraged the transfer of mechanical technology as well. Machinery such as tractors, tillers, broadcast seeders, and the grain carts were introduced to the beneficiaries of Green Revolution. I think I got that quote, if I remember correctly, from Rubenstein, the Cultural Landscape book. How can a country benefit from all of this if they can't get it to the farmers? And so that's the problem that we had in Africa. That's the reason why. And that's what you need to remember if you don't write anything else down. You know that India, Pakistan, Mexico, these are places where the Green Revolution were helpful. Parts of East Asia, Green Revolution is helpful. But if you're looking at Africa, which is where today we have the highest natural increase rates in the world, and where they say over the next 100 years, you're going to see the most population growth collectively, how in the world are we going to help them? Because the Green Revolution has failed in those regions. Also, hybrid seeds require more fertilizer, as I just mentioned, but fertilizer was made using fossil fuels. All right, there's a big chunk of Tex and Rubenstein talking about that as well. And they were too expensive for many LDCs, kind of coinciding with what we were just not talking about. Let me get this out of the way. Fuel costs are too high to run machinery needed for producing hybrid crops. So again, for us, the reason why places like Africa struggles with Green Revolution. Another issue with Africa is this issue of limited farmland. All right, so you guys may or may not have heard of desertification, but this word means that there is an expansion of desert in Africa. And it's one of the most endangered areas of desertification. In fact, the Saharan desert is literally growing by an impressive amount. I can't tell you how many miles or whatever it expands a year or whatever it is, but I mean, it's growing at impressive rates. You can see that the places in red are the ones that are in, it says very high risk of desertification. That's happening along the Mediterranean coast, as well as this Sahel region, just kind of to the south of the Saharan desert. So another reason for this is because of overgrazing. A lot of the people here, we're going to talk about agricultural regions next week, by the way. And one of the things we're going to talk about is nomadic herders. There's a lot of people that practice nomadic herding in this region here. And when they do that, that means they're walking animals around again and again and again, looking for grazing land for their animals. Well, overgrazing has helped to proliferate or spread even more rapidly this desertification we're talking about. So not only are you looking at bad infrastructure, but you're also looking at limited farmland and limited water. There's that map blown up so you can see it a little bit better. I forgot that put it in there. So this area here, these are rainforests, and then for the most part, there's low risk of desertification, but you can definitely see that that's a big deal. So biotechnology. By the way, I saw that if the AP Bio group was talking about biotechnology this week. So if you're taking AP biology, I don't know how in the world you can do both, but if you are, you might want to tune into that. But biotechnology is the use of genetically altered crops in agriculture and DNA manipulation in livestock in order to increase production. All right. So what we're looking at here with biotech is kind of like what Borlaug was doing when he's making these hybrid seeds. It maybe takes it a little step further. This is going on in a lab. Okay, this isn't like you're not on a field figuring this out by whatever you're doing with wheat. These guys actually are in labs scientifically breeding together different types of crops and creating something that is a better product. And this here is how they create several things. One that I don't know if people need to know by name, but it's definitely something you should know about in conjunction with the Green Revolution, is IR36. What this is a type of miracle rice that was created in biotech labs, in the Philippines in the year 1980. And what they do is they take rice, they make it extremely high yield, kind of like they did with the wheat. Right? They're able to make it resistant to pests, drought resistant under harsher conditions. It can survive. It matures faster, so you can actually get multiple harvests. This is known as double cropping, when you're able to get 2 harvests from one growing season. And then they also were able to adapt this kind of technology into corn later on, as recently as, I believe, the 1980s or 1990s. So another thing, I don't know if I have it in here or not, with this rice is that they were able to begin, I think I do have it in here actually, so I'm not going to get ahead of myself yet. But this is the thing. So the Green Revolution initially radically improved the amount of yields of cereal crops. What I mean by cereal crops is anything that is like your wheat, rice, corn, any of that stuff. Those are known as cereal or grain type crops. Right? The reason why breakfast cereal is called cereal is because a lot of that is made out of those different types of material. Essentially, the next step in selective breeding is kind of what's going on. It's kind of like how people are going to characterize the Green Revolution. People have been doing this for a long time, plants and animals. I'm just going to show you a few things here. This is a picture of ancient corn and modern corn. It didn't just happen overnight accidentally. This happened because of people selectively breeding corn over the course of 10,000 years, however long corn has been a thing. Probably not quite that long, but pretty close to it. Here's other pictures that show you've got natural variation that would occur in wild populations of any crop, really, of any animal. When people start to cultivate, and we talked last week about the word cultivate means to care for or to grow it on your own. When you got people cultivating it, they get to choose what crops are going to continue on. So you heard about Darwinism. You hear about things like Charles Darwin's selective breeding, not selective breeding, natural selection. All right, where just naturally the fittest are going to survive. In this case, this is not natural selection. This is human selective breeding. Right? So we create it this way by taking the best seeds and growing them into whatever we want to be. And over time, we get bigger crops because we've chosen which ones are able to continue because we're cultivating the land, right? This is ancient wheat. This is super modern wheat, hybridized and bred. You can see how much bigger and how much higher yields they are able to produce. I don't know if you guys ever seen people beating wheat on like the road or something like that, and with these tools or whatever they use, and this is called threshing, and they were able to separate the heads or the stalks of wheat, and then you're there to, I don't know, grind it up, make flour and stuff you make bread out of. Rude! Did I say something rude? Thank you. Thanks, John. I appreciate it. I tried. The next phase of selective breeding, well, that maybe the next step of this is to look at GMOs. And again, some people are going to say, we're still in the Green Revolution. Well, there's a difference kind of between what plant hybridization is in the way that Borlaug was doing it and what GMOs are. GMO, it stands for genetically modified organism. Anybody ever heard of GMO? You guys ever heard of genetically modified crops or GM crops or any of that stuff? Yeah, it's something that really a lot of people, even in the United States, aren't familiar with what that means, and it's interesting. Right? There is a massive anti-GMO movement. You're right about that. That's picking up steam, in particular in our country, but we are still extremely, as a nation, very, very pro-GMO, and we're going to talk about that a little bit. You're right. More and more non-GMO products are for sale. Another thing, too, about GMO products is that a lot of the people that are producing non-GMO products are choosing to label them non-GMO, even though there's no legislation for making it where we have to do that, which is one thing that a lot of people would like to see happen, because in Europe, those laws are there. Scientifically and ethically, is it good or bad to have GMOs? We're actually going to talk about that in just a second. So we'll look back at that question in a minute. It is extremely debatable, and I'm going to show y'all my favorite source on the GMO debate. And I'm even going to talk about how I use that for my own students. So I would challenge y'all to listen to it, be about a 55-minute debate of these scientists going back and forth on whether or not GMOs are good or bad. But I'm going to show you guys a little bit about them and let y'all decide that on your own, and we'll talk a little bit about the pros and cons. But a GMO is an organism that has its genome changed in a way that does not occur naturally. I know I changed that definition to what was in the AMSCO book. Apparently it didn't say, there it is right there. Okay, I just didn't delete the slide. A GMO they're plants or animals that scientists in a laboratory modify by extracting genes of one species and inserting them into the DNA of another species. Wow, that's like God stuff, isn't it? There are several ways you can do this, all right? Probably the one that is, I think, the most popular is by adding the genes, like we say here in this definition, from other species into a different, like a plant or an animal, or whatever it might be. There are also ways of editing genes, and that right there, I think, is a little bit, from what I've read, a little bit more taboo. I think we've only just started to do this with certain foods, like maybe mushrooms, but I'm gonna try to slow down. All right, I'm just trying to make sure I get through it in time for us to be done in an hour. But heck yeah, I want to try to slow down for you. All right, so in other words, we modify the DNA of plants and animals. GM, in other words, genetically modified crops, are designed for several reasons. All right, first of all, the idea here is that you can add these different types of genes from other species to make plants more pest or environment resistant. Pests are like any kind of bugs. Environment is, like for example, in the South, I just saw this, I'm from South Carolina. I just saw this meme on my Instagram that says, what time is winter? Winter is at 8 o'clock in the morning. Spring is at 11 o'clock, or, fall is at 4 o'clock, so on and so forth, because our weather is so crazy. I mean, right now, today, it was probably in the upper 70s. I'm not even gonna lie. It was awesome. Tomorrow, it's probably gonna be like 30 degrees and freeze. So what some people have done is, with things like tomatoes, for example, you put in the genes from a certain type of fish, it will prevent the tomatoes from having freezes and make them last longer. So what have you done? You essentially put this weird gene into your tomatoes, but you increase the yields because you don't lose as much product, and people are able to eat that tomato and buy it in the store. It also can cause, you can add genes to cause plants to live longer and also make them more nutritious. One of the examples with the more nutritious, and here's what I was talking about a little while ago, is golden rice. One thing that these biotech scientists did was they start to embed, or I guess imbue somehow, a certain type of gene that can enable rice to contain lots of vitamin A or beta carotene or whatever it is that can prevent kids from having blindness due to malnourishment in some of the poorest parts of the world. And so here's an example of increasing nutrition in the food. Mushrooms that don't go brown could soon be on sale thanks to a loophole in GM food regulations. I found this article just yesterday. It's from 2016, and there's a snip from the article. It says the edited mushrooms can stay on shelves for longer and don't need to be handled as delicately as regular strains, reducing waste and saving money for consumers, farmers, and retailers. Any of you guys know that we were editing the genetic makeup of mushrooms in 2016? I didn't know. So anyway, we're going to talk about the implications in a minute. And here's another example, the papaya. There's a disease that it gets called ring spot virus that makes it look ugly. Who wants to eat that? Right? But you can actually buy a GMO papaya that is resistant to that virus so that it looks pretty. You're probably more likely to pick up a pretty one in the store, aren't you? So there's not really a necessity for getting rid of the ring spot virus. From what I understand, it doesn't really affect the fruit at all. But you can get one that doesn't have nasty spots. People might be more likely to buy it. So there is a commercial side to this as well. We've got a question. Are any of y'all, or all GMOs unhealthy and harmful? Dylan, that is part of the debate. When you look at what scientists are going to say about it, they're going to say no. They're tested. They're perfectly safe. It's not going to hurt anything in terms of if humans consume them. But there are plenty of people that disagree with that. For example, in Europe, they won't buy GM crops. They just don't do it. They're like, we want to take things as organic as we can possibly get. There are some people that say, well, we can do GM and organic, and yeah, but nobody wants to modify their plant in that way in certain parts of the world. And so the United States, honestly, we can live our lives and not know that we're eating GM crops because it's so accepted here. But in other parts of the world, in other parts of the developed world, it is not. And so, thank you there. Yeah, Alex, that's exactly right. And sometimes you'll hear people use the word GM for genetic modification. So you definitely want to know both. GMO tomatoes. I'm going to read a little bit of this because it's hard to see. But hang on, I'm done answering this. So I'll put that there. Why is a GMO tomato? A GMO tomato is genetically modified fruit using genetic engineering to ensure longer shelf life. So in other words, you can sell more of it. They're going to not go bad so fast. How are GMO tomatoes used? Tomatoes are used to attract customers to grocery stores and also to feed our growing population. GM tomatoes are injected with different genes, including fish genes, which I just told you about, and so on and so forth. Drought tolerance. Let's see, that's a con. I'm not sure why that would be a con. Pros of GMOs: increased food supply. GMO tomatoes resist antibiotic, whatever that says, and increased pest and disease resistance. So there are some kind of good associated with it. There's also some negative as well. This one here, I followed Chris Harria's workout YouTube channel, and I was watching a video about what he eats the other day, and he's talking about how just a video, it's like 8 or 9 minutes long about why he buys and grocery and what he eats. And he has this onion, y'all. It's honest to God, probably the biggest single onion I've ever seen in my life. And people like in the comments, they're just going on and on about this giant onion. And this guy says, dude, I'm so shocked. I knew everything in the U.S. was big cars, big house, but look at this onion. It's like 3 times bigger than those I buy in France. It's crazy. Dude down here says GMO. I mean, it's no, they don't know what we have here in the United States. Are GMOs, we got a question. Are GMOs viable for countries within the semi-periphery periphery? That's part of what they are designed for. Okay, that's part of the debate. That's part of the good side of the debate. See, scientists are saying we are able to turn around some of the hunger that's happening in some of the poorest parts, in particular in Africa, by using GM crops, because it can help them to not have to use a lot of the fertilizers and pesticides and things like that that are usually associated with Green Revolution. So, by the way, what we mean by semi-periphery and periphery is the periphery states are going to be the poorest countries on Earth, the ones that are outside of the global core. And the semi-periphery would be usually something like a stage 3 country in demographic transition, like maybe Mexico or Southeast Asia or the Middle East. If you got rid of GMOs, they'd still be able to support the demand for food. Proponents against GMOs would absolutely say yes, they can. And so that's again part of the debate. People that say that they're pro GMO are like, well, this is one way we can easily kind of fix, maybe the next step to fixing the Malthus issue, the Malthus problem, and some of these places where agriculture hasn't, I guess, where Green Revolution wasn't so successful. But I forgot to hit the little button. But people that are against GMOs, absolutely, they say there are things we can do to still produce enough food to support us even without using the GM crops. So it's just really depends on how you look at it. GMOs are lauded by supporters as the next possible end of hunger, as I just said, and the next phase of human modification of agriculture to solve world's problem versus food production. By the way, when we talk about GMOs applied to vegetables, cotton, soybeans, any of that stuff, it can also, there's medicinal purposes. Insulin is used for using GMOs. That's really good. You know, anyone who's diabetic, chances are they're using some form of GM in their insulin. Cotton is clothes. We're not going to eat that, so it can't kill us, right? It can produce more cotton to help us have cheaper clothes at Walmart or wherever it is we go and buy our clothes. Lauded, that means they are celebrated. Or I have a question here. Lauded means that it's going to be celebrated by supporters, or they're going to say that this is the reason why we need to use them. So essentially, again, you might have more food, less waste. Tomatoes don't freeze because of the fish gene, whatever it might be. Corn increasingly is used in fuel production. So you guys ever heard of ethanol fuel? Well, that is created by corn. In fact, the majority of the corn that we grow in the United States is grown for animal feed a lot of it is grown for ethanol, and we probably eat less than either one of the two of those. We can grow corn, in circumstances, I guess any GM crop, in circumstances that reduce the need of some fertilizers and pesticides. Hey, real quick, that right there is also debatable, because some of the people against GM crops argue that, in fact, some of your biotech companies like Monsanto, which is probably the biggest name, they have their hands in all kinds of things related to agribusiness, which is when one company might control a lot of different parts of the agricultural process. And that's part of the debate, is that if you have large companies like Monsanto that say, hey, we have these GM crops you guys can use. Oh, but we also have Roundup, which is their thing, is an herbicide to kill weeds, and they will make their GM crops resistant to Roundup. So you can spray the heck out of your crops with herbicide, all right, kill all the weeds and get high yields from GM crops without affecting the product. The problem is people don't want to have to eat crops that have been sucking up Roundup all this time. Monsanto controls soybean industries. Monsanto has a lot of say in that, absolutely, because if you eat soybeans or corn in the United States, odds are it is absolutely a GM crop, whether you like it or not. And you probably didn't know that, but this the God's honest truth. Here we got a question. So some GMOs require certain chemicals to unlock the traits so that unwanted hybrids don't happen? I honestly don't know the answer to that question, but that is one thing. In particular, my boy Bill Nye used to be kind of anti-GMO. Now, he's recently switched his allegiance in favor of GM crops, just to let you know. But one of the things that he suggests is, or he suggested, was that you might have an environmental issue you can cause by GMOs. For example, if you, and I think I've got this in my PowerPoint somewhere, but if you have a situation where you have a GM crop that is going to kill a certain type of pest when it tries to invade the crop, well, if another insect eats that pest, then that insect might go extinct because now that pest doesn't exist, which might cause other animals that eat that animal to go extinct. And meanwhile, these different genes might be supplanted into other plants to make them more weed resistant through things like pollination and whatnot. So there is a lot of people that are kind of afraid that this chain reaction might cause environmental issues. And I don't really know what the definitive answer to that is. So really, a lot of people are going to say, we know beyond any shadow of a doubt that GM crops are healthy for people to consume. We might not be as sure about the whole environmental disaster side of it, and maybe we need more time. Who knows? In the United States, if you eat soybeans or corn, it's most certainly GM. I just mentioned that. Problems with GM crops include things like health problems, perhaps, may reduce the effectiveness of antibiotics. If you take antibiotics, they may not work as well. There are studies that suggest that maybe that's true, and some that might say maybe not. I had a neighbor just next door to me who is got the disease where you can't eat glutens. Okay, so he has to eat everything gluten-free. He also tries his hardest to eat everything organic, specifically to stay away from GM crops, because when I was talking to him about it, he's like, I don't know what all this stuff is and how it might affect my health, but I feel healthier, like I can breathe better and not have the issues with when I eat regular organic food. And so something that a lot of people are choosing to do because they don't know for sure if it's healthier or if it's not. Disrupting long-standing ecological balance of local agriculture, that's the one I was just now talking about in the last question. I have a question. If a company makes a specific GMO, could they patent it? Like, could they get a percentage of the profit every time it's bought? Absolutely, they can. All right, and that is again the other side of the kind of like why Europeans and even African countries are hesitant to get GM crops from the United States, because, like I just now said, overwhelmingly Monsanto is one of the ones that has the most fingers in the GM pot. If they're producing seeds that are genetically modified for people in Africa, for example, to grow, what's Africa's biggest market? It's going to be Europe. So you have this dependency on buying crops that will grow under those harsh conditions from a U.S. agribusiness company that may not be beneficial for them in terms of selling to the market. Another thing, too, is that Africans are kind of afraid that that Monsanto and other companies would have the ability to create a terminator gene. This is in the Rubenstein book, something that would prevent them from being able to take the seeds from the crop and replant them, meaning they would have to continually buy from U.S. agribusiness companies again and again, which is definitely something that that could possibly happen, even though we say that's not going to happen. There's no way of knowing it. So people that are against GM crops would say that it would cause us to be more dependent on the United States for those to be supplied. So there is, I mean, really, when you talk about the implications of GM crops, it is literally political, it's economic, it's way more than just trying to increase yields, because people that are against it are many, and there's a lot of people that are against it. But in the United States and among the science world, people are actually very, very pro-GMO. This one here comes from Bill Nye's book that he wrote in 2014. If you're asking me, we should stop introducing genes from one species into another, Nye writes, because we just can't know what will happen to other species, that modified species ecosystem. In other words, he's saying that who knows what's going to happen if those genes end up somehow being more supplanted into another species, maybe even a weed, or maybe some kind of a plant or another crop. We just don't know. These are the problems I just kind of mentioned. So we look at the places in the developed world on the periphery that this is supposed to help. It may not be as helpful as you think when you look at things like how they might benefit or not benefit from GM crops. While the United States is all about its GM crops, Europe is not, and they would be Africa's biggest market. So a lot of people in African countries are very hesitant to buy GM crops from the United States because of that. Also, because of the power that companies like Monsanto would have on the sale of GM crops, it would create a dependency on the United States. The debate continues, and it has implications for you guys. And that's the reason why we're talking about it in geography. If you ask, or I guess ask yourself, how much of this stuff did you guys know about GMs before you took AP Human Geography? And if you're just hearing about it right now from me, you're going to hear some more of this most likely in your class discussions, because it's a big part of agriculture today. It has implications for all of us. Did you know that you absolutely eat GM crops in your cereal, pasta, bread, processed foods, etc.? Does it matter that the United States is the world's biggest GM producing country? Are the crops better for the world, or is it just good for the United States if the world thinks they are? Now, one more thing too that I really want to point out is, as I'm going over this presentation, I feel like I am almost biased against GM crops in my presentation, but and I never ever tell my students this, but in real life, I don't necessarily believe that they're a bad thing. I'm just going to go ahead and say that. You also have a lot of people in the science world are going to say that let's please not say things like that. If you do that, I'm going to boot you out. You also have things like Bill Nye, Neil deGrasse Tyson, and many other scientists, or most scientists, are going to say this is something that is a really good thing for humanity. From a spatial standpoint, GMOs are excellent as they are seemingly conserve space whilst also increasing yields. Absolutely, absolutely. So and there are more. So one of the things I really want you guys to be able to see is this right here, where I say the best GMO debate. This is a podcast from NPR in 2014-ish. I would highly recommend you guys go in and watch this debate, or listen to it. It's a podcast, so some of you will listen to it. You can download it and listen to it on your phone, on the bus, or whatever it is. I would definitely take the time to look at that one right there, the NPR article, before you do anything else, because it is really insightful. And consider which side do you think wins, and try to approach it from an unbiased standpoint. But one side, I think, clearly, and my students usually will think the same thing, one side clearly has the better argument for whether or not this is good or bad. Maybe even take notes on it, because you will learn something from it. There is this Eyes of Nye video, and this video there's a little mini series that Bill Nye did. It's all on YouTube. But if you look up the Eyes of Nye GMO debate, it's about a 26-minute article video where it's kind of silly, but he talks a little bit about this. And this here is when Bill Nye was a little bit more anti-GM crop. Today he is way more pro-GM crop. Article 1, this is an article that I found that I think is pretty easy to digest. I'm gonna put that on my Facebook page as well, but I put that there for you guys. There's a Green Revolution video about Norman Borlaug, which is really good. And then Dan Snyder's YouTube channel, I don't know if you guys have seen that or not, but covers a lot of material for the course. Very good, helpful resource. This here is his video he did on the Green Revolution, and I think he even talks about GMOs in there as well. So might be worth looking at if you want an 8-minute summary on the day before the test. Or, as always, you can sign up for Fiveable Plus, and you'll be able to see it in a timestamp when we start talking about all these things. So here's the summary. We talked about the Green Revolution, how it emerged in the mid-1900s with the creation of hybridized cereal crops. Green Revolution was not successful in Africa. It was successful in places with better infrastructure. GM crops are created scientifically in labs, and they enable food to last longer and grow under harsher conditions. But they're also super controversial. As one of you guys mentioned earlier, even in the United States, there is a increasing movement against them as people are trying to get more fresh grown organic fruit and vegetables or whatever else it might be. GMOs have spatial implications. The U.S. tries to sell GM crops and are economically invested in their success. There's all kinds of other ramifications as well that we already mentioned. So that does it for me. Do you guys have any questions before we go? I appreciate it, Robert. And like always, if you guys really enjoyed it and you think that your buddies or your teachers in other schools or whatever it might be will benefit from being here, the live reviews are going to be free from now on, every Thursday from 7 to 8. Let your buddies know. If it's helpful for you, it'll be helpful for them too. Hope you guys have a good night, and I have a question. Let me answer it real quick. I think it helped me study. This was a very thorough review. It will definitely be here next week. Awesome. I appreciate it. You guys have, how do I complete the C? Oh, I don't know what that is. I guess it's for everybody. You guys have a good night. Peace out.